Hey guys, welcome back. Hope you guys are doing well. So today let's solve the problem from Leetcode platform daily challenges. Okay, which is design, add and search words data structure. Okay, let's read the question. Design a data structure that supports adding new words and finding if a string matches any previously added string. Implement the word dictionary class. Word dictionary initializes the object. Void add word function adds word to the data structure. It can be matched later. Okay. Bool search word function returns true if there is any string in the data structure that matches word or false otherwise. Word may contain dots. Okay, here we go. Word may contain dots where dots can be matched with any letter. Okay, this problem could be easy if this condition will not be there, right? Okay, anyway, let's think how to approach this problem. So this problem seems like they will be given a set of words. First, we have to implement a dictionary such that we have to store them all of them into the dictionary. And later they will give a pattern like to search that word, and we have to search and return a boolean value where we have to say if that word exists in our dictionary, we should return true. Otherwise, we should return false. We have to return false, right? So okay. So let's see how can we approach this problem. Um, let's take some examples. Like okay, you know that whenever becomes problems, whenever we encounter problems, these kind of problems like searching words and inserting them into the dictionary, we always go choose for the best data structure, which is nothing but try data structure, right? So let's approach this problem using try data structure. What is try data structure? This is nothing but it stores all the words in dictionary format such that all the strings whose prefixes are same will be stored only at one time. That means it is going to save a lot of time as well as space. So let's see. So for example, let us consider initially we have words that are inserted into the dictionary which are AC, AE, BC and BD, and they are inserted into a try data structure as you can see here. We have root node of try data structure and AC is inserted here, and similarly AE, BC and B, right? Now these are the words that we have to search for. So let's say we have to search for AC. Then what we have to do, from root onwards we should start searching, right? So in order to search AC, first we have to search for A. Yes, we have found it here. And then we have to search for C. Yes, we have found here. So and this is the end of the end of the word, and there are no more present, no more words present. So uh, the definitely that AC word is present in our try data structure. So this is found. We will return true. And next word is B, and we'll search for B from root node. Yes, we found B here, and the next character is E. And as you can see here, after B there is no character exist, which is E. Only two characters, that is C and E. So we will look for the other, E, but we are unable to find it, so we'll return false. So we don't find B, so we'll return false. So what next? Next is dot C. And yes, as you can see here in question it says that the dot can be matched with any character, right? So let's say first, so it can be matched with any character. We are going to match with all the characters and see if that means we have to check for every possibility that matching every character with the dot character and moving further. So for example, at first position we have dot, so we can replace the dot with any character. And in our try data structure we have two characters, that is A and B at first position. So first let us consider the dot character is replaced with A, and we have to look further, that means which is C. Okay, let's search for C. Yes, we have found it here. That means we have replaced dot with A and C. That we have replaced dot with A and look further, and we have found C, which is nothing but this dot C can be replaced with AC. And yes, we have found that word which is exist in our try data structure, so we will return true in this case. Okay, I hope you guys are getting. And next let's search for what dot Z. Okay, so For this dot can be replaced with any character. Let's start by replacing it with a character A, and we will look further, which is Z. So we'll look for the second character, which is Z, and as you can see, after A we don't find Z, we only find C and E. So this is not working. So what next? This dot can be replaced with anyone, right? So we found that after replacing the dot character with A, we are not going to find any word that is matching with the given one. So we are moving further and matching that character dot character with B, and look further, and dot Z, next character is Z. So as you can see, after even after replacing the dot character with B, we don't find the next character, which is Z. So this is also not working. And similarly, we are going to look further, but there are no characters which are exist. So we can't find any word which is matching with this word, so we'll return false. I hope you guys are getting. So let's go to the code implementation, so you will get better understanding there, I hope so. So in order to do that, the first thing we have to do is implement a try data structure. I will say it as try. And in order to track that which word is ending at which position, we should take a boolean value like bool is in, so that this value denotes that there exists a word which ends at a particular position. And each character or each node consists of 26 characters, right? For that I was going to take like all pointers of size 26, array of pointers size 26. So initially all of them are false, and all the children are null values. These children represents the characters. Okay, so initially we have no characters, so all of them are null. Okay, so let's consider first as a root, which is a global variable, and this word dictionary initializes the object, which is nothing but our try data structure. So initially let's create a try data structure, which is we are going to initialize our root value with 0 words. So add word, this is let's insert this word into our root data structure. For that, take a temporary pointer and to insert the and we are going to iterate over all the characters and inserted them into our try data structure. So if word of y minus this gives us whatever the character may be, this is going to convert them in the integer range from 0 to 25, and that is nothing but our total number of characters are 26, right? That is 0 to 25, we are going to convert them. And we are going to see that at that position, if there exists any particular character, if there exists already a particular character, then we are not going to create any new node, and we are simply moving to the position. Otherwise, if there does not exist anything, so we are going to create a new node like stephen of dollar point minus a total new node, and then after we are moving there, right? Yes, after completing all of these steps, so at last, since this word is ending here, I have to make this boolean variable, which is end, to be set to true, right? Okay, we have successfully completed the insert word, add word, and we have to search for that. So in order to do that, let's implement another function like which includes uh, our root, that means from where we have to search for, where we have to start searching. from which node we have to start searching. So you will get a more clarification if we implement that, like search in try, and in starting position we are searching from root onwards, right? Okay, let's implement this function. And then, as we have done before, similarly we are going to do that. And I was going to search for each character till the end of the word. And this is for each term. In order to convert that character into the range from 0 to 25, first I will take like int is equal to word of I minus, and then, so what if that character is dot, we have to check that condition, right? If word of I is equal to dot, if that is dot, then this dot can be this dot character can be matched with any characters, right? So I will iterate all the characters that are present in our data structure at that position, and assume that the character dot character is replaced with that character and move further. Let's say so this for loop is to uh, substitute that dot character with all the characters that are present in our data structure, and if there exists any word that matches, then we are going to return true. Like if um, if this particular character exists here, then the children of j is not going to be null, right? Yes, not going to be null. And since we are replacing this character, um, we have to search for from the next substring, right? This is like a search in try, and we have to pass this character, this node, which we are at present node, and the substring, that means what dot string. This is nothing but, so as you can see here, while we are replacing this dot character with a and moving further, that means, and moving further, which is we are searching for c from this a, that means we are searching from a, and the word is c, which is nothing but this is substring from all the string from after the dot character, and the node that we are start searching from is this a node, which is at current node. This is what I was doing. This dim dot children represents the current node from where we have to search, and this word dot substring that we are going to search is nothing but the remaining string after the dot character, which is nothing but, so if dot character exists at ith position, then I need to search for the I plus 1 from I plus 1 to the overall string, right? And if found, we will simply return true. Otherwise, after replacing that dot character with every character that is present in our data structure, still we are unable to find the string, then we are going to return false here, right? And if the dot character, the character that we are searching for is not a dot character, then that character should definitely exist in our data structure, right? If not, then we are going to return false. This is like temp of children of ind is equal to null, then I will return false, or else I will move further for checking the next character. And after we have found that entire the word is present in our data structure, and at last we have to return if that is the end word, right? So this is like return is end. This is because even though there exists a word which is even though our try data structure contains a word whose prefix is equal to the word that we are currently searching. So in order to check that whether that word exists or not, So if that word exists in our data structure, then definitely after completing the word, then we are going to make this is and boolean value as true, as in above function, right? So we have to check if there exists a word, then definitely after all searching the end of the word, this end is and boolean value should be true. That returns there exists a word in our data structure. So that's why we are returning temp.isEnd is true. Okay, let's run this code. Okay, I was made somewhere mistake. This is not no. This is that got accepted. So let's submit this. Yeah, guys, it got accepted. And that's it, guys, from today. If you know more optimized solution rather than this, please feel free to comment in comment section so that I will learn from you guys. Okay, and thank you, guys. That's it from today, and catch up tomorrow.